Hello, good evening to all of you, and welcome to Unacademy. Welcome once again to our NCERT initiative, where we are approaching the NCERTs, the complete coverage of the NCERTs of class 11th and 12th, and we are taking a different approach as compared to what you would have been exposed from your childhood days or from your overall preparation. We have basically ensured that geography is something which is covered in a very visualistic manner. We have ensured that rote learning is not forced upon you. And we have ensured that each and every topic and chapter, unless and until it is visualized by you, it is understood in greater conceptual depth by you, we don't move ahead. So, in that endeavor, we continue and we come to the last chapter of geomorphology in the portion of our fundamentals of physical geography, and that is the formation of landforms. Now, formation of landforms is again one of those areas whereby candidates oftentimes struggle in order to memorize, retain these landforms owing to the theoretical nature of it. Again, forming one of the weak areas for the aspirants for the examination. This is a particular chapter which is relevant both for your prelims as well as mains examination. UPSC has been known to ask direct questions out of this, both in the prelims as well as mains, as is the trend. And as we have been following, we will basically use the case of the animations and the videos in order to ensure that even this chapter becomes visualistically appetizing and it is something which you can digest. If you have been following this series, your feedback is very valuable to us. So do put that in the comment section if you are liking this initiative. Don't forget to click on the like button and share it with your friends, and do subscribe to the channel for all the other subjects as well. Now, starting first of all with the landforms, basically, when we talk about the case of these landforms are created how? Various different agents of nature. When we talk about the agents of nature, there are various different agents of nature. Here in your image, you can see the case of the sea waves, right? To the case of underground formation. All of this, these are considered to be the agents of nature, the river movement, etc. Now, as they tend to move, they end up eroding materials, depositing materials. Yesterday, we talked about the process of gradation, isn't it? Gradation means leveling of the land. So these agents of nature, they carry out that process of gradation. And by that process of gradation, they end up creating the different types of landforms. So this is the chapter which talks about the landforms and their evolution. Any kind of land feature which is there. And let's suppose a mountain is there, a region which has got mountainous terrain and mountainous territories. Even this region, over a period of time, will be leveled down. Over a period of time, you will find that the winds, the rivers, the rainfall, weathering, mass movement, everything would have reduced its size almost to a plain like feature, with maybe one odd isolated hill like structure here or there. So that is basically the case of these landforms. Now, the agents of nature that we talk about, there are various agents of nature, from the case of the river water, to the case of groundwater, to the case of glaciers as well. Then you have the case of the winds and the sea waves and the winds. So these are the agents of nature, each of them creating their own unique kind of landforms, and that is what we are going to be observing. Now, eventually, what happens is that, see, any particular kind of agent of nature, like a river. Now, when a river does move, when a river does originate, it generally originates from a greater height. And then it flows down the hill slopes with a greater speed, with a very high speed, right? Now, initially, When you talk about the river movement, it can be classified into various different stages depending upon the property that the river indicates. Broadly, it is classified into three types. One is the youthful stage or the young stage. Now, at the young stage or the youthful stage, the river comes down the slope with a great speed. And as it comes down the slope with a great speed, it will always have the case of erosional activity. It will basically hit the rocks with a great force, and that is where it will start eroding. For example, let me show it to you with the help of one of the animations. Observe, as the river is coming and falling down, it is creating that erosional structure. Why? Because of the force that the river induces, the river water, the force that it induces. So that is why when the river is in its youthful stage, at that point of time, speed of the river is very high. Speed of the river is very high. And you will find that whenever the speed of the river is very high, erosion will be also very high. Rate of erosion will also be very high, isn't it? Here you will find the formation of deep valleys and gorges. Gorges. Those will be created, right? Then, slowly and steadily, you will observe that as you come into the second stage, the mature stage, the speed tends to reduce because the slope tends to reduce. Now, the river has already come down the mountain slope. So, here, the speed reduces. It is still there, but it is reduced as compared to the earlier case. So, speed reduces. As the speed tends to reduce, thereby what happens? Erosion will happen, but deposition also is started. Deposition begins. And that is where you will find the formation of plains and the plain areas. And eventually, so I always say this in the classes also, when you have to basically take a look at the river systems, always associate the stages with the life cycle of a human also. When a human is young, in the youthful stage, full of energy, right? Running around, bubbling around, energy level is very, very high. You'll break things, you'll break your head as well, but still you will keep on running around. Same is the case with the river as well. When it is youthful, very high energy, it will break things, it will carry things along with itself. When you become mature, you basically become a bit measured, right? You don't run around that much. Same is the case with the rivers. When they become mature, the speed reduces. That is when it starts creating the case of the flood plains. And when a human becomes old, energy level is very, very low, flows very slowly. That is the case where only deposition is observed, no erosion. Okay? Only deposition, deltaic formation, etc. So that is the case of the stages of river movement. Based upon that, let us see and analyze how the various different landforms created by the rivers, they basically evolve. So here, when we talk about the various different stages of river, this is mentioned here, right? So we will analyze the landforms also. In the youthful stage, when the river is in its youthful stage, at that point of time, river basically is coming down the slope with very high speed. And that is when it cuts the land almost vertically. If you observe this land, it has been cut almost vertically, isn't it? So here is where at the base you will find the river to be flowing. So this vertical cut created by the river, this is what is also referred to as a gorge. Gorges get created. It is not George, by the way. It is a gorge. So gorges get created like this. Now, one of the feature of the gorges that you will find to be present is you have vertical side walls. Okay. You will have the presence of vertical side walls in this particular case. Many such gorges exist in India in the region of Himalayas. For example, when you talk about River Indus, when it enters into India, it creates a gorge where the height of the nearest mountain is almost 5 kilometers. So you can imagine how much amount of cutting action had been carried out by the river. When you talk about Brahmaputra, you oftentimes come across the news story that China is building a dam across river Brahmaputra. All of you would have heard about it, that China is building a dam. And that too, if I show it to you in the background image, this is where Brahmaputra tends to flow, right? China is building a dam here. This is also known as the Great Bend. It is here that a very deep gorge has been created. The height of the nearest mountain from that gorge is 7.7 kilometers. So you can think about it, that how deep that gorge is. So that is why China is looking to block that water in that great depth. That is why it is going to be one of the biggest dams ever constructed by mankind across the globe. So that is basically where you have these gorges in the youthful stage, and you basically, we humans, we are unable to imagine the power that the rivers have. Rivers have so much of power, they continue to hit the rocks again and again and again, and over a period of millions of years they will always degrade and break the rocks regardless of the kinds of rocks, right? Three Gorges Dam is present in a different place. Three Gorges Dam is present across river Yangtze. China is constructing a dam across Brahmaputra at the region of the Great Bend. So both of them are very different. Now, here, many of the times, the rivers basically create a kind of a structure where the walls are not so steep, the walls are gentle. This is what is referred to as a valley. So you have the formation of these valleys also. So, how these valleys would have evolved? So, just to give you an idea, at one point of time, the river would have come from an area like this. Okay. And the river would have been flowing like this. Now, over a period of time, the river would have cut this region deeper and deeper and deeper. And you would have the evolution of a landform which went slightly deeper. The river would have cut it further. This would have gotten slightly more deeper, right? The river would have further cut it, and eventually you have the formation of a valley like structure. Okay, so that is the valley which gets created. The Valley of Kashmir, that you famously is also referred to as the Vale of Kashmir, that is also has been created by this kind of a also combined action of glacier, but river movement has also been a major factor in that particular case. So these are formed in a very youthful stage of the river movement. I hope this is understood. Now, another aspect I want you to understand, these gorges over a period of time can automatically get converted into valleys automatically. How? So if you imagine this, this is the stage of a gorge. Now, over a period of time, remember yesterday we talked about the case of weathering, isn't it? So, over a period of time, these areas will undergo or experience some or the other kind of weathering activity. So, the rocks basically will get weakened, they will get broken down. And after that, they can fall in the form of a landslide, rock fall, mud flow, anything that we have talked about yesterday. And as a consequence of this mass movement, all these materials are getting deposited, right? And what do you have eventually as a formation? Eventually, as a formation, you will have the case of a V shaped valley. Okay, so that is basically how a gorge can get converted into a valley like structure. Okay, but then This is something that is found absolutely close to the point where the river is originating. For example, near the Gangotri Glacier, you will find this. In Tibetan region where Indus originates, in where Satluj originates, where Brahmaputra originates, there you will find these. But as river comes down the slope, for example, imagine a region like Rishikesh, where river Ganga comes down the slope with a great speed. Now, in those areas, you don't observe these valleys and gorges, you observe different landforms. Like what? You observe something like a pothole. This is what is referred to as a pothole. Okay. This gets created on the riverbed. Okay. So basically, for example, now when you see these potholes, immediately your mind goes to the Indian roads. But this is not on a road, this is basically a riverbed. These are not very large in size. At max, if it is very large, it will fit an adult human. That's as max as it can go. Otherwise, these are smaller. So, how do these potholes get created? The mechanism is very simple and unique here to be understood easily by logic. Let's suppose this is your riverbed and this is the river water which is flowing down. Now, the river water, as it is coming down the slope, it will have a speed. It will move with a high speed. The speed will be high, isn't it? Now, here, if let's suppose there is a rock which is kept at the riverbed, now the river water will carry that rock along with it. That is how much force it has. Now, this rock will be carried by the river water, but will it be carried till eternity or till the end to the sea? No, the rock is also heavy. So, the rock, as soon as it is carried, it will try to hit the ground. Again, it will be lifted by the river. Again, it will be carried further. Now, whichever regions the rock has hit the ground, in those areas, there will be a slight depression which will be created due to the huge force exerted by the rock on the riverbed. Now, let's suppose this rock has been carried away somewhere far away. Now, if another river or another rock is being carried by the river, automatically it will be drawn towards that depression. Why? Because in that depressed area, the water will have its own current type of a circulation. It will try to draw every material in that hole. And like that, multiple stones will hit it, multiple rocks will hit this, and you have the formation of what is known as a pothole. That is how potholes get created on the riverbed. So, this is basically created on the riverbed. Guys, the easiest way to cover this chapter is through visualization. If you follow the method of retention by learning the definition, let me guarantee it to you that you will forget it within 1 week. That is a guarantee from my side. Okay. The only way that you will retain anything from this is just by the case of visualization, looking at the images, looking at the animations. Okay. So that is the difference between the candidates who are able to score in this chapter and the candidates who till 1 day prior to the prelims they will keep on running for notes and definition. So visualize it, and that is why we have put up these images. Yes, definitions will always complicate your learning. Now, then you have the case of waterfalls and plunge pools. Waterfalls and plunge pools. Okay. Now, what is a plunge pool? How do these waterfalls and plunge pools get created? Have you ever thought about it? That why will a waterfall get created? You would have rectified about the highest waterfall in the world, the largest, highest waterfall in India. That is something that you would have learned. But why a waterfall gets created? So, whenever you have the alternate arrangement of a hard rock and a soft rock basically indicating the case of a sedimentary rock, hard rock indicating, let's suppose, an igneous rock. Okay. Now, it is always easy to erode the sedimentary or the soft rock. These are weaker rocks. So, when the water follows that pattern, it will always erode the soft rocks and thereby create a kind of a waterfall structure. Waterfalls can also be created whenever, let's suppose, you have a case of a landmass. Let's suppose there is a landmass like this. Okay. And let's suppose a river is moving here. Okay. Now, if this portion of land, if you consider, if this portion of land is uplifted because of the internal heat of planet Earth, interior heat of planet Earth, there is a quick upliftment. Then what will happen? It will create a structure somewhat like this. Isn't it? This portion has been uplifted now. Now, when the river which was moving, the river will experience a gradient of land. So here you will have the case of a waterfall. So upliftment of land can also create a waterfall, particularly in the regions like Chota Nagpur Plateau. That is the waterfalls that you observe in Jharkhand, Chhattisgarh, Odisha, Karnataka. In these areas, the waterfalls that you experience, they have been created because of the upliftment of land. Okay. But the waterfalls that you observe, for example, in the Himalayas, right? Those waterfalls have been created because of erosional activity. Okay. So it depends on where you are experiencing that kind of a waterfall. Okay. So here, basically, when we talk about the Himalayan rivers, they would have created a waterfall because of the erosional activity. Now, observe this place at the bottom. Now, water is falling continuously at that particular base. Over a period of time, the force of water will be so very high, it will hit the rocks continuously. So, how is the water falling? If I draw the cross section of this, water is falling like this and then forming a flow, isn't it? Now, continuous hitting of the water at the base, day in and day out, it will deepen this area. It will erode this area. And that is what ends up creating what is referred to as a plunge pool. That is why at the base of the waterfall, always it is advised never to stand at the base of the waterfall. If you like water falling on your head, better to stand underneath a shower. Why? Because these plunge pools, they get very deep, right? Suddenly you will find that if you are an individual who is standing here, water is coming to your waist, but the moment you take another step, it basically moves above your head, and the falling water doesn't allow you to come up very easily. That is why every year maximum drowning does happen in the plunge pools, even in our country. Smallest of the waterfalls like the Hundru Falls, the Dasham Falls, etc., in Chota Nagpur Plateau will have many casualties year after year. You have these casualties. Now, the government has put up the boards in various different places that please do not go into these plunge pools. It can be of greater depth, but the citizenry class that we are, wherever the government tells us not to go, we generally like to go there. We want to see for ourselves why is it that the board is put up? That is why every year a lot of casualties do happen in this. Okay, that is the case of the formation of plunge pools. Now, this is the case of the valley which is indicated, which is formed by the Kaveri River. Okay. Then you have a very interesting kind of a formation, which is known as a meander. Meander and thereby the formation of the Oxbow Lake. Now, what is a meander? Meander is when the river does not move in a straight path, but rather than takes a curvy path. This is what is referred to as a meander. So, when does it happen? Whenever the gradient becomes very gentle, the river does not move with a great speed. The river speed reduces. That is when it basically tends to have a meandering path. Now, when the meanders basically get created, and understand this very simply, why does a meander get created? Meander. So, a meander will get created because of certain factors. First is lower speed. Now, why do you have a lower speed? Because of the gentle gradient. Gentle gradient, isn't it? You also have the case of the factors such as the Coriolis force, etc., but not very relevant here. Just understand the case of a gentle gradient here. Over a period of time, so imagine you have the river which is like this. Okay. Now, how is the water going to flow? Water is going to flow here, isn't it? Now, water will create a greater force in which region? In this area, it will hit with a greater force. Over a period of time, this portion will get eroded. In this region, also, water will create a greater force. It will hit with a greater force. It will also get further eroded. Like that, with the passage of time, you will observe that the meander has basically become like this. Again, very so slightly, Manisha, not in a significant manner, but very slightly. Again, you will observe that the water is flowing like this. So basically, it will have a kind of an erosional pattern again following like this, isn't it? As this continues to happen, it is like a riverbank erosion. As this continues to happen, you will observe that this meander becomes so curved that water will hit here also. And eventually, let's suppose these two bodies join. Then water will find a shortcut and will start flowing from here. So, this portion will be separated. So, this separated portion, observe the separated portion. The separated portion is what is referred to as an oxbow lake as well. Observe the satellite imagery of the formation of a meander and thereby the separation of an oxbow lake. You will observe in this image that how the meander keeps on getting more and more curved, and observe this, that this is an oxbow lake. Okay. For example, you have Kavartal in Bihar, which is a Ramsar site. It's also an oxbow lake, right? So, like that, you have many of the oxbow lakes which eventually end up getting created or getting formed. Okay. Now, this is basically the formation of a meander and an oxbow lake. Yes, because the shape is that of the hump of the ox, very correct. That is why the name is Oxbow Lake. Okay. Now, At the base of the meanders in this region, whatever deposition you observe in this area, observe the deposition in these areas, right? You would have observed these. These are your point bars. These kind of depositions, they are known as point bars. Okay? Then thereafter, if you observe this, there is something which is also very unique that is known as incised meander. Incised, incision means as if something has been carved out, something has been cut out. That is the case of the incision or the incised meanders. So, whenever you have a meander in any particular region, means the speed of the flow is very less. Now, yesterday we studied a kind of an endogenic force which pushes the land upwards. Okay. Whenever you have any kind of endogenic force which pushes the land upwards, what is that endogenic force known as? Remember, we had talked about the case of catastrophic force and diastrophic force. So, which kind of force induces the vertical upward and downward movement of land? Epirogenic or orogenic? It is the apirogenic. Orogenic is associated with the horizontal movement. Will abandoned part get connected with the river? It can get connected during the rainy season, but dry season again disconnected. Okay. So, whenever you have apirogenic movement means upward movement of land, upward movement of land, isn't it? Now, thereby, you will observe what? That if this is a meander and the land suddenly moves upward, will the river also move up? No, the river will continue to follow its own path. Why will the river continue to follow its own path? So, here, very simple to understand. If you imagine a landform, let's suppose this is the landmass. Okay. The river has been moving here. Okay. Let's suppose this portion, small subsection, experiences upliftment of land. Now, upliftment will not happen within a day. Upliftment will take time. Let's suppose the upliftment happens at 1 millimeter every year. Okay. So, in 1 year, it will be uplifted by 1 millimeter or 1 millimeter every 2 years, let's suppose. Now, the river bed will also get uplifted by 1 millimeter. Right. So, if you imagine the river bed, this is the river bed and this is the river flow. If the river bed in small section gets uplifted by 1 millimeter, what will the water do? Water will erode this very quickly. It will basically reduce it to the same size. And like that, the river continues to maintain its own height, whereas the surrounding regions, they experience an uplift. So that is where it appears that the meander has been cut into these rocks. Hence the name incised meanders. Example, observe this. This is an incised meander in a river named Rio Grande. Rio Grande is a river which originates in the US and forms the natural border between US and Mexico. Here, if you observe, the river is at the bottom and the surrounding regions have been uplifted, isn't it? The surrounding regions have been uplifted. So here, the river continued to erode its own bed. Surrounding areas have been disturbed. That is the case of an incised meander. Okay. Now, as the river flows, it will also deposit, particularly at the time when it meets the sea. At that point of time, it creates the most fertile depositional region, that is what is known as a delta. Why the name delta, by the way? Because thousands of years ago, you had the Greek scholar Eratosthenes. Eratosthenes, when he visited Egypt, at that point of time, he observed the region of river Nile. It was Eratosthenes, in fact, who gave the name Egypt being the gift of Nile, that you would have learned throughout your childhood days in the GK books, that which is the gift of Nile, ma'am, Egypt. You would have learned that. So it was Eratosthenes who said that the Egyptian civilization is basically the gift of Nile. Now, Eratosthenes, when he followed the river Nile, he observed a large depositional feature which very much resembled the Greek alphabet delta. And that is where the name delta came from. The Greek alphabets alpha, beta, delta, theta, gamma, all of these, omega, all of these are Greek alphabets. This resembled delta, and hence the name delta was provided. Here you will find the finest sediments, the smallest of the sediments, very fertile, very fertile. Okay, smallest sediments in existence. Okay, largest delta in the world is Sundarbans Delta. You can grow anything, rice, for example, in majority of the deltaic stretches, paddy is cultivated. If food grains are majorly the cultivational aspect or the crops which are grown in the delta. Sundarbans Delta famous for the rice cultivation. Okay, this is where you have a lot of people in Sundarbans Delta who are now migrating away from Sundarbans Delta because the sea level is rising and the sea water is coming inwards. Okay, so a lot of people from the region of Bangladesh, from the region of the southern part of West Bengal, they are moving inwards because of the flooding of the Sundarbans Delta. Okay, now delta can be of different shapes, by the way, and that is where the name also is associated. You have the for example, you have the Cascade Delta, Arcuate Delta, etc. Here in this image, what you observe is a unique shape of the delta, not given in the NCERT, but you should be aware. Observe this unique shape of a delta. This appears to be like the foot of a bird in terms of its extension. It is extending into the sea. This is what is famously referred to as the bird foot delta. Bird foot delta. Now, bird foot delta, this is created, this is actually the formation of a delta by river Mississippi. Okay, Mississippi, which drains into the region of Gulf of Mexico. Gulf of Mexico, which Mr. Trump is eager to name as Gulf of America, but still being referred to as Gulf of Mexico. So that is where you have this bird foot delta, which has been created. Okay, now then we have the landforms created underground by the action of the water, rainwater, river water, and overall groundwater. These kind of landforms which are created underground, this is what is also referred to as karst topography. Why? Why the name karst topography? Because for the first time, when it was found, it was discovered, it was actually found to be present in the karst region of Yugoslavia. That is why it was referred to as karst topography, that this kind of a landform famous for karst region. But it is found in various different places in India also. In Meghalaya, for example, in Karnataka, the very famous Yana caves in Karnataka, the Cherrapunji Mosindram region in Meghalaya. All these areas you will find the presence of this karst topography. Where will you find this karst topography to be present? Water can be present on the surface and underground everywhere, but you don't have these kind of structures everywhere. It is only to be found in those areas where the bedrocks or these bottom rocks, they are rich in minerals like limestone, calcium based minerals like limestone. Okay. Now, why we are saying calcium based minerals? Basically, as a consequence of this, whenever you have excess water, calcium gets dissolved. And as calcium gets dissolved by water, these holes and large caves end up getting created. Over a period of time, the entire region is filled up. And as the water table goes down, these are left as the underground structures. This animation depicts it with great clarity. Observe that how initially you have the entire region in the underground structures, the calcium and other kind of such minerals getting dissolved. They are dissolved in water, and some portions thereby cavities are created as a consequence of that dissolution. Now, when the water level is emptied, caves and such depositions get created, together known as the case of karst topography. Okay. So when you talk about the karst, you have the case of various structures. For example, you can have large holes getting created, known as sinkholes. Sinkholes. Now, these sinkholes can be very large, by the way, very, very large. It can be many, many meters in diameter. Then you can also have the formation of these underground cave structures, large caves. You had the case of the students being trapped in the region of Thailand, and as a consequence of these caves, very frequented by the waves, they can always get flooded, people get trapped, and here also casualties do occur. Okay, so initially you can have the sinkholes. These sinkholes, they can combine together. When they combine, you form that valley sinks, continued formation, what is known as a valley sink or an uvala. Okay. Eventually, these sinkholes, they are, as you can see, quite large in diameter. Many of the sinkholes, if they are together, they combine to form a kind of a valley sink, which is known as an uvala. Okay. Now, thereby, you also have other structures in the caves which get created, and that is where you will find the formation of some depositional features also. So basically, let's suppose you have a cave like structure. Let's suppose you have a kind of a cave. Okay. Now, here, this is the bedrock above the cave. Now, if water which is falling, if this water seeps in, it will be dissolving those kind of minerals like calcium, etc. Right? Eventually, the water droplet will form here, and maybe the water evaporates here itself. When the water evaporates, it will leave behind the salt that it had dissolved attached to the roof. And such multiple kind of evaporations create. It almost appears like wax-like structures are hanging from the walls, right? This is what is known as stalactite and stalagmite. These stalactites and stalagmites, they can also combine together, and that forms a column or a pillar. So the portion which is hanging from the walls, that is known as the stalactite. The portion protruding from the ground, that is known as your stalagmite. Okay? If you have any doubts up till now, do let me know. Now, then we come across the most massive force that planet Earth's surface experiences, that is in the form of glaciers. What are these glaciers? This is not ice, by the way. It appears like ice. These are not ice, by the way. This is basically the calcium, some magnesium, some amount of silicates, etc., which the water had dissolved, and now the water has left it and evaporated. That is what these are, the hanging structures. It appears like ice structures, but these are not ice. You can relate it to the freezer. Yes, perfect. When you open up the refrigerator, you observe the freezer, you will observe this kind of an icicle like structure, right? Almost something similar. Okay. Quantity of water is high at the old stage, the erosion is zero. It is not less, it is zero. Okay. It is basically the case of the speed. The speed of water or the speed of any force of nature is the one which determines the structure which gets created, or the erosion which happens. If the speed is high, erosion will be high. If the speed is very low, deposition will occur. At the old stage, speed is very low, so only deposition will occur. Orogenic and epirogenic forces, we discussed about it yesterday. With the help of animations and everything, we have discussed it yesterday itself. Kindly take a look into that and you will be able to understand that. Now we come across some of the most mightiest forces of nature in the form of glaciers. Now, when we say glaciers, glaciers are what? Glaciers are basically moving mass of ice. Okay. Ice which comes down the slope with a very high speed, or not a very high speed, very low speed rather. Ice which comes down the slope at a very low speed. That is glacier. So glaciers are moving masses of ice. Masses of ice. Okay. So why is it the case that ice will come down the slope? So understand this. It is simple. Understand this. Let's suppose you have a mountain. Now, beyond a certain height, rainwater won't fall. You will have the snowfall, which will happen as you move higher up. Snowfall will happen because of lower temperature, isn't it? There will be a kind of an immense amount of snowfall which will happen. Now, over a period of time, year after year, lot of this snowfall will happen. Now, what will happen to the snow? It will get compressed. It will get converted into thick ice over a period of hundreds of years. This will get converted into very thick ice. Now, this ice very slowly will start moving down the slope, isn't it? It will start moving down the slope. And as it starts moving down the slope, its height reduces, it will start to melt. And that is when it gets converted into water and that feeds the rivers. So, that is basically this moving mass of ice is what we refer to as a case of a glacier. Now, these glaciers, avalanches are also experienced in these areas also. Yes. Avalanches are basically when you have this new snow. For example, let's suppose for 5 days, the region has received snowfall. There is too much of loose snow. It has not converted into thick ice. Now, that loose snow will try to fall down the slope. That is what is an avalanche. Okay. So, avalanche is basically the case of the loose snow falling down the slope. Okay. Now, in this case, when the glaciers move, the glaciers exert a lot of pressure on the rock surface, thereby being able to smoothen the rock surface and creating unique landforms. For example, the image that you see on the screen is that of a glacier. You can see the glacial ice falling down. This is the glacier which you observe at the base of Mount Everest, near the base camp of Mount Everest. So the climbers of Mount Everest, they first have to move through this region of this glacial ice. Now here it might appear as if you have easy snow to move over, but it is not like that. I will show you the zoomed in image of this. If you zoom into this is what the glacier does appear to look like. Okay, just for comparison, the size of adult humans. Okay, so this is how very large, massive blocks of ice, they basically rub against the rocks, and you have a very haunting, a daunting, screeching sound which gets created. And that is why, if you fall in between these, death is almost certain. It can be a 3-story, 4-story fall in between these gaps. That is how large these blocks of ice are. Almost like a 4-story building, 5-story building. That is how large they are. Now, when you consider these glaciers, they rub against the rocks. Okay, they rub against the rocks. They will carry these rocks, and owing to the pressure exerted from above, the rocks will further break down into very tiny particles. And that tiny particle eventually is deposited by the glacier, what is referred to as the glacial till, something that we had discussed in the evidences for the continental drift theory as well. So, observe this image. You will observe that how the glaciers basically end up eroding the base, right? And when is it available to for us to be able to see this? Only when the glaciers have disappeared. Only when the glaciers have melted out, then we are able to see these kind of valley-like structures. So that is basically the case of the glacial erosion. Okay. Now, I want you to take a look at this particular map. This is the map of the last ice age of planet Earth. During the last ice age, all these areas of planet Earth were frozen. Okay, all these areas were frozen. Now, it is in these areas where now the ice has melted, and now the glacial erosion and depositional sites are available to be visited in these areas. So, the glacial landforms that you see, for example, in the region of Himalayas, it is still not something that you will be able to see because this is still frozen, isn't it? But then, if you observe these areas, here the glacial ice has melted out. So that is where Western Europe, North America, you will find lot of these glacial landforms. Okay. Antarctica is also still frozen, so glacial landforms not easily visible. Now, what are the landforms? One of the unique landform is what is known as a cirque. What is a cirque? Look at this image. Imagine that at one point of time, a massive glacier would have flowed down the slope like this, right? So, this glacier has created an erosional structure which appears to be like an amphitheater. That is a cirque. Erosional structure which basically is like an amphitheater. At the bottom, a glacial lake has been created. This is what is known as a glacial lake. Okay. Observe this animation. You will observe that here you have the formation of tiny glacial lake at the end of it also. Isn't it? Why? Because wherever the glacier has eroded a lot, a depression has been created, melt water accumulates, and you have the formation of glacial lake. Now, if I ask you, what if a large rock from here falls into this glacial lake as a result of mass movement? What will happen? The water immediately will overflow and will flow down the slope with a great speed. It will cause floods. That is what is known as glacial lake outburst floods, something which impacts the regions like Sikkim. Sikkim is impacted by GLOFs almost every year. Okay. Then you have a unique structure which is known as a horn. What is a horn? Observe this. This is the very famous Matterhorn peak in Switzerland, a very famous tourist site. Now, if you observe this, so basically you will observe that there is a kind of erosional activity. Both sides, the cirques would have been created, both sides, leaving behind a peak like structure. That is what is referred to as a horn, a unique peak like structure being created. Glacial events are not seasonal. Glacial events, it is not as if during summers you will not have glaciers, only during winters you will have glaciers. No. Glaciers you will observe to be in existence in many parts of the world during the ice ages or otherwise at great heights. Okay. Now, this is the case of the Matterhorn in Switzerland. It is a individual peak-like structure. Then you have another unique glacial erosion structure, which UPSC had asked directly in the mains exam. That is a fjord. What is a fjord? Fjords basically are very deep valley like structures created in the coastal areas of Norway, Greenland, Antarctica, New Zealand. In those areas, you will find that you have these erosional structures where now you have water, right? Sea water entering in. These are your fjords. But at one point of time, these were basically the glaciers which were moving. That is why you will find that the coastal area of Norway, if you draw the map, they are not straight. Coastal area of Canada, if you draw the map, they are not straight. Coastal area of Greenland is not straight. New Zealand is not straight. Like our Western Ghats is straight. But these areas, you'll find there is a lot of indentation. All of this is created because of the glacial erosion. That is a fjord. So, how do these fjords get created? So, earlier you could have these areas, you can imagine that a river would have been flowing, emptying into the sea. Ice ages come every few thousand years on planet Earth, where these regions get frozen. Now, when the ice ages would have come, the glaciers would have moved from various different places, right? Further eroded and created the deep U shaped valleys. Okay. And eventually, these valleys would have been eroded to such an extent that now the seawater moves inwards. So that is why you have the salty water or saline water created in these fjords. So these are basically your erosional structure known as your fjords. Okay. So that is basically, and understand it very simple. Whenever you have ice age, everything gets frozen. When everything gets frozen, sea level will drop, right? Sea level drops, more erosion happens by the glaciers, deep depressions are created, seawater enters inwards. Okay. Then you also have depositional structure like moraines. So when the glacier moves, it deposits materials. These depositional materials, these are known as moraines. Depending upon where the deposition has happened, accordingly it is named by that category. For example, if the deposition has happened at the end of the glacier, it is known as a terminal moraine. If it has happened in the middle of the glacier, here, this is a medial moraine. Medial moraine. Okay. So moraines are basically your depositional structures created by the glaciers. Then you have the case of drumlins. These are again depositional structure where basically the glacier leaves behind a kind of a depositional structure like this, right? These are created again in areas like Western Europe, Northern America, etc., whereby if you imagine this could have been the landscape before the ice age and the glacier is moving slowly and steadily, it would have deposited certain materials in its path. As the glacial ice has melted, these are the structures which have been left behind. So that is what is known as a drumlin. Okay. So till is the particle, very fine particle, that is known as the glacial till. The structure that it creates, the deposition that it creates, that is known as the moraine. Okay. For example, river carries silt, but it creates a flood plain. Similarly, till creates outwash plain and moraines. Okay. So this is what drumlins appear to look like. Then they are basically around quarter of a mile or more in length. And that is streamlined by the glacier flow. And that is why the shape is like this. Then you have very linear deposits also done by glacier. Observe these deposits. You observe them. It is not like a drumlin. It is a very linear kind of a deposit. That is known as an esker. Eskers are linear deposits at the bottom of the glacier. Bottom of the glacier. Okay. Those are known as eskers. Okay. Eventually, they turn out to be very fertile. They are also made out of till deposits. Glacial till would have created these kind of deposits. So, what is till? The finest particle which eventually the glacier carries and ends up depositing in different regions. Then we come across the landforms which are generally created as a consequence of sea waves. Now, you see, in the coastal areas, the sea waves, with their physical force and also the salty water, they end up creating both physical erosion, chemical weathering also, and chemical erosion also. And that is where they create structures like caves, etc., beaches. All these are created by the sea waves. So the sea waves, oftentimes they deposit the materials, they erode the rocks and deposit the fine particles, which creates a kind of a beach-like structure. So when you go to a sea beach, older the sea beach, that means the particles would be finer because the finest particles are deposited and larger particles are degraded to small size. So smaller particles you will find in the older sea beaches in existence. Okay. Now, the sea beaches, they also end up creating large cliff. For example, you will observe this that here you have, let's suppose earlier, the landform would have been like this. Now, continuous hammering by the sea waves, what it has done, it has created a structure almost vertical. This is what is known as a cliff. You'll find it across the Scottish Highlands, across Britain's coastline. In India, you find it across Varkala in Kerala. Okay, that is where you find them to be present in India, where you have these cliffs getting created across sedimentary rocks. They can be created across limestone beaches as well. Okay, now here many of the times the sea waves, they basically will end up slowly and steadily breaking the rocks. Okay, breaking the rocks, and that creates a series of structure. Initially you will find that you can have these cave like structure getting created by chemical weathering, chemical erosion, etc. Caves can get created, and these caves, if let's suppose the water manages to erode the entirety of the structure, the caves get converted into arches. Now, arches, their roof is weak. This will be very weak roof. Roof will collapse, isn't it? That is where they create these stacks and stumps. So all these are your coastal landform, found very massively in large numbers in the region, for example, Mediterranean coastline. Okay. In the region like Mediterranean coastline, you will find that these kind of structures are very common. Why? Because Mediterranean coastline is very old, right? Indian coastline is still evolving. Eastern coastline of India is so old that you don't have the rocky structures at all. Mediterranean coastline still has igneous rocks where you have these kind of erosions which do occur. Now, then after that, coming to the case of wind erosion. Now, wind erosion basically ends up creating the kind of landforms which are known as aeolian landforms. Now, wind based landforms will be observed wherever the wind speed is the highest in those areas. Now, where is the wind speed going to be the highest? In the region of deserts and semi arid areas, deserts and semi arid regions. Okay. So, that is where you'll find, for example, even in Rajasthan, you will find these kind of structures where, example, this is what is a mushroom rock or a mushroom table. So, what happens in this? You see, a rock would have been present like this. Now, when a wind would have blown, it would have carried the sand particles near your home. Also, you would have observed, for example, that when you have very strong winds, larger particles are carried closer to the ground, smaller particles are carried at a greater height. So, these larger particles, they will hit the bottom, finer particles will move near the top. So, over a period of time, this will get eroded. Smaller particle, they will erode it. Like this, the structure evolves. And you have the formation of these mushroom tables. Victoria Desert in Australia, one of those areas, right? Thar Desert, Rajasthan, one of those areas. This is quite commonly found in all these areas overall. Okay. Now, then you also have what is known as the deflation hollows. What are deflation hollows? Basically, when you observe the desert areas do not necessarily have the same quality of sand or the fine particled sand everywhere. Eventually, the mushroom hollows will break. Desert areas will have large particles of sand also, small particles of sand also. And when you observe that wind is very strong, the fine particled sand is eroded by the wind, whereas the larger coarse grained sand is left behind. This creates an erosional structure which are known as deflation hollows. Now, all these materials which are eroded eventually will get deposited in the form of large structures which are known as dunes, sand dunes. Sand dunes are basically the structures which get deposited. These are the depositional structures. So, depending upon how the wind has been, that is how sand will get accumulated. So you have the classification as longitudinal dunes. If the wind is coming from all sides, you have the formation of a star shaped dune. If the wind is moving only in one direction, transverse dunes which are parallel to each other, right? Transverse dunes have been used for centuries by the traders and travelers, where they would actually move in the shelter of the dune to prevent themselves from exposure of very strong winds. When the dune becomes very large, what happens? This central portion, it is made out of sand. It can simply collapse, isn't it? It is made out of loose sand. They can simply collapse. When they collapse, they create a structure which is almost like the shape of a crescent. And that is what is referred to as a barchan. So, barchans are your crescent shaped dunes. Okay. These are your crescent shaped dunes where the central portion has simply collapsed. In many particular places, the wind erosion, particularly in dry areas which are surrounded by hills and mountains, wind erosion basically erodes the base also to such an extent that a small basin gets created, and that closed basin, a shallow depression or closed basin, right, it can have the presence of some amount of water. Okay, water, where does the water come from? Let's suppose seasonal rainfall has occurred in these areas. All that water will accumulate, it will carry out the mineral deposits from these areas also, and it will be a water which will be very salty. It will have various different minerals which will be trapped, and it will create a very shallow lake. Okay, eventually you have the water which will evaporate and the minerals will be left behind. Okay. Now, multiple repetition of the process means the minerals will start to dominate and the minerals will start to be present. Eventually, a flat, hard, fine grained surface having these salt crusts, they remain, which can have seasonal availability of water. Those are known as playas. Okay. For example, in the western part of China, that is the Xinjiang region, you will find the presence of these playas. In the region, what we have studied in our mapping classes, we have studied about the region around what? The Altiplano. Altiplano is present in which region? In the area of Bolivia, right? In the region of Bolivia, in those areas, to the south of it also, between the Andean ranges, there also you have the case. In the Atacama region also, you have these playa areas. Many of those saltwater lakes known as the Salars, Salar de Hombre, Salar de Uyuni, now those are also very rich in lithium reserves. Same is the case in western part of China also. There you will also have the formation of the finest particles of wind deposit, what is known as loess. Okay, so basically, we come to the end of the topic. A quick recap of the landforms that we have discussed. Now, when we talk about the landforms created by running water, now those landforms are known as your fluvial landforms, right? Now, which are the landforms that we discussed? We discussed about the valleys and gorges. We discussed about the potholes and the plunge pools, right? Plunge pools. We discussed about the case of even waterfalls, meanders and oxbow lakes. Then we talked about the case of incised meanders. Then groundwater, karst topography, karst topography. Then coastal landforms, glacial landforms, and aeolian landforms. Do one thing. All the landforms that we have studied, under these headings, make it a note or write it in the comment section. Let that be your revision. And we meet again tomorrow And tomorrow we initiate the discussion of climatology. And that will be very, very important because that will lay the foundation for all the various different climatological chapters from cyclones to the wind movement. Everything will depend upon the tomorrow's basic session. Let me know about the various landforms in the comment section. If you have liked the session, put that in the comment section, and we will continue the discussion tomorrow. Don't forget to share it with your friends and like the video. No MCQs tomorrow. Today we will have the MCQs tomorrow. Take care. Goodbye. Thank you.